ChatGPT and every other AI chatbot has one massive weakness. It can lie to you with total confidence and it doesn't even know that it's happening. There is one piece of architecture that fixes this and it is called as RAG. And by the end of this video, you will understand it better than most engineers do. Let's break it down. RAG stands for Retrieval-Augmented Generation. Don't worry about the fancy name yet, just look at the picture. A user asks a question, it goes to database, finds the answer and related fact about the question, and sends it to the AI brain to compose the final answer. Now let's understand why this is even necessary in the first place. Okay, let's decode the letters one at a time. R is for retrieval. That means finding relevant facts from an external database. A is for augmented, which adds those retrieved facts to the user's original question. And then there is a G, which is generation. That means asking AI to write the final answer using only the provided facts. First retrieval, then augmentation, and then generation. Keep that sequence in mind because it is a backbone of whatever we are going to learn today. Okay, so what is this problem that RAG is exactly solving for us? Let's take a look into it. Consider that an normal AI model is like a closed book exam taking student. It has two massive problems. First one is it's frozen in time. So every AI model is trained on some data in the past and it has memory of only up until the cutoff date of that training data. So if you ask any AI model about yesterday's news, it doesn't know the answer. It only knows the answer until that particular date that it was trained on. Now you can ask, how does ChatGPT knows about the latest news then? ChatGPT knows about the latest news because it uses a tool called as web search. That is how it is fetching data from the internet. It doesn't fetch the data from its memory. Second problem is no private access. If you are using any AI model for only your company and you want it to answer in something according to your company's policies and documents, it cannot answer you because you have not given it any access. So two things will happen in that case. It will either answer something from the past, whatever is relatable it finds from its memory, or it will give you some wrong answer. So basically, AI model is smart, but it works on the memory. Now, here comes RAG in the picture. RAG is the solution of the exact problem that we have seen in the previous slide. RAG turns AI into an open book exam from the closed book one. How? It provides the source material to the student right before the exam. So it can go through the material, read through it, find the answer, and write the answer. That is called as external knowledge. That means we are providing AI some source material that it should refer whenever answering the question. Now, in this case, we are not testing AI's memory power, but we are testing AI's reading comprehension. And reading comprehension is much more trustable than memorization. So, what happens when the model doesn't know the answer? It doesn't say, I don't know, but it guesses the answer, and that even very confidently. This is called as hallucination. Large language models are advanced autocomplete engines. When they are missing information, they create some information, they create an answer that looks correct, but it is not. And this is the single biggest trust problem in AI today. And that is exactly the problem RAG was built to fix. Here is a full pipeline in 3 steps. Step 1 is ingest. That means external data and files are loaded into the vector database. Then comes step 2, that is retrieve. User's question is used to pull the most relevant information from the database. And in generate, AI combines that retrieved information to generate the most accurate and relevant answer to the question. Now let's zoom into each of these steps of this pipeline. Now let's zoom into each piece of this pipeline, one component at a time. First problem is AI can't read massive 500-page manual in 1 second. So finding an answer to a question, it cannot just go through the whole document at once and then find an answer for you. It is very time consuming and it is not a feasible solution. So the answer to the problem or the solution to this problem is called as chunking. That means breaking down the document into some smaller pieces called as chunks, which are usually some paragraphs or few sentences. So how AI works with that is whenever user enters something or asks something, it fetches only the chunk that is relevant to that information and answer the question through it instead of the whole document. Next problem is computers don't understand language, they understand math. That's where embeddings come in. An embedding model translates human language into a list of numbers called vectors that capture the actual meaning of the text. So the word apple doesn't just become a random number, those numbers represent its meaning in a way that computer can compare and search through it. Now, where do all these number-based meanings live? They live in a vector database, which is a specialized database like Chroma or Pinecone that store this numbers list. And because embeddings does not match only the element but it matches the meanings, that's why elements with similar meanings are embedded together. So apple as a fruit will be closer to banana, which is a fruit, and apple as a tech company will be placed near to the smartphone, which is the related to tech. So this lets system search by concept and not just matching keywords, which is a massive upgrade over old school search. So how do we find the right chunks that are related to our question? That's the job of the retriever. When the user asks something like how much annual leave do I get? That question gets converted into numbers using the same embedding method that we just talked about. Database then performs a similarity search, finding the stored chunks that are mathematically closest to the user's question. Same match space, same meaning, matching trick, just applied to the search instead of storage. We have retrieved the facts. Now for the final two steps, augment and generate. We take the user's original question, add the retrieved context. For example, employees receive 20 days of annual leave and combine both into a single prompt for the AI. That prompt basically says, you are a helpful assistant. Use only the following context to answer the user's question. The LLM then reads the context, processes the question, generates a fluent, factual response based on entirely the provided data, and does not guess it. Now let's see how this works in reality with a real example of customer support. Now, on the one side, without track, when a user asks question to the model, that is, how do I set up the Salesforce integration? The model is giving a very generic and unhelpful answer. That is, you can integrate Salesforce by going into settings, and if you need help, contact support. Very unhelpful. On the other side, with the RAG model, when user is asking the same question, the system is pulling the document from the company's database and it's giving the exact steps that user has to take to set up the Salesforce integration. And it is also giving the document that it has cited, which is accurate and personalized. So it's the same question, same AI model, but completely different quality of answer, just because one version had access to the right facts. Now, why companies are so obsessed with RAG right now? There are three big reasons for this. First is it eradicates hallucinations. Answers are grounded in actual company data, which massively boost a user trust. Always up to date. When a policy changes, you simply update the document in the database, and no expensive retraining is needed. Third is transparency and citations. RAG can tell users exactly where it got the answer, linking straight back to the source material, which boosts the trust. RAG is very powerful, but it still has some limitations, which are first is trash in, trash out. If your internal documents are outdated, contradictory, or poorly formatted, the AI will confidently serve you a bad answer. Second, the chunking challenge. If chunks are too large and AI gets confused, too small, it loses the important context. Added latency. Searching a vector database adds millisecond to response time compared to the AI purely answering from its memory. People often confuse RAG with other technique called fine-tuning. So let's clear this up. Path A, RAG, the open book. It is giving the AI access to library or facts to look up at runtime. Path B is fine-tuning, which is back to school. Continuing to train AI model on specific data to teach it new tone, communication style, or highly specialized skill. One gives AI the fact, the other changes the AI's behavior, which are two totally different jobs. So which one should you use actually? Here is a quick cheat sheet. First, need to update knowledge instantly? You should use RAG. You need to stop hallucination? Use RAG. You want AI to learn brand's tone and style? Use fine tuning. According to setup cost and time, RAG is low cost and fast. On the other side, fine tuning is high cost but slow. So RAG is undisputed champion for factual accuracy and dynamic information. Fine tuning, on the other hand, is best for teaching an AI how to sound like your own brand. So the core insight of this video is separate knowledge from reasoning. Large language models are incredible reasoning engines, but terrible databases. RAG succeeds because it separates the two. It lets database hold the fact and lets LLM do the reading, synthesizing, and writing. Stop asking the AI to remember everything and just make sure that it can look things up. Let's lock this in with three simple steps. Retrieve. The system searches a vector database for relevant chunks. Augment. Those chunks get bundled together with the user's question. And generate. AI reads the provided facts and generate a highly accurate citation-backed response. Retrieve, augment, generate. That's RAG. Thanks for watching. If you found this helpful, don't forget to like, subscribe and share. I'll see you in the next video. Bye bye.